In the frozen dark beyond Mars, an interstellar traveler has begun to breathe. Its name is 3IATLAS, a glowing green enigma that releases poison into the void as if alive. Hydrogen cyanide spills from its core in perfect rhythm, defying science and reason. Data vanishes each time it exhales. Monitoring stations fall silent. Some say the chemistry is spreading, infecting nearby dust, rewriting the language of matter itself. Others whisper that this is no comet but a messenger, carrying the same molecules that once shaped our own creation. From the toxic skies of ancient Earth to the black silence of deep space, a terrifying symmetry unfolds. Tonight we follow the evidence, the missing signals, and the patterns that should not exist. Stay until the end, because what begins as poison may reveal the oldest secret the universe still hides. It began quietly, with a flicker of light that most telescopes would have ignored. But something inside 3IATLAS stirred, and from the void came a faint, poisonous breath. Astronomers watched as the interstellar traveler started releasing hydrogen cyanide, a molecule that destroys living tissue and suffocates any atmosphere it touches. To some, it looked like a routine process of outgassing, the natural venting of trapped chemicals as sunlight warms the surface. Yet this one felt different. The pattern was too organized, too deliberate, as if something within the object had awakened on cue. The first. Measurements came from deep space observatories tracking its trajectory near 2.1 astronomical units from the Sun. That's where the activity began, as though a switch had been flipped. Every few hours, plumes of toxic gas pulsed outward in perfect timing, like the heartbeat of a living thing. Scientists called it fascinating. Others called it frightening. Because hydrogen cyanide doesn't just appear in that concentration by chance. It needs heat, energy, and a chemical reaction that shouldn't exist in the vacuum of space. Some researchers suggested solar radiation triggered it, but that doesn't explain the rhythm. Others thought the molecule was trapped ice, slowly thawing, but that fails too. Hydrogen cyanide breaks down easily under sunlight. If it was simply evaporating, it would have vanished quickly. Instead, Atlas kept producing more. Each emission seemed to feed on the last, creating a steady plume that glowed faintly against the black backdrop of space. The pattern hinted at internal chemistry that regenerates itself, something unseen in any known comet. What if 3IATLAS isn't behaving as a comet at all? Some astronomers began comparing it to Oumuamua, the first interstellar visitor that baffled science with its acceleration and shape. Atlas, however, shows signs of reactivity, not motion. It isn't running from gravity, it's reacting to it. The object seems to respond to energy fields as though absorbing and reusing them. The deeper question becomes whether this is chemistry or intention. Could something buried inside be controlling when and how it releases toxins? When the plume first appeared, the data showed faint fluctuations in electromagnetic readings. Tiny shifts, but synchronized with each pulse of gas. The coincidence was unsettling. It was as though the release of poison was tied to an unseen field, one that hummed softly through the solar wind. The timing became impossible to ignore. Each emission followed the same mathematical rhythm. In biology, that pattern resembles metabolic cycles. In technology, it resembles signaling. No one wants to say it out loud, but the comparisons are there. Some astrophysicists now study Atlas not as an inert object, but as a reactive system. A few even describe it as chemically intelligent, a phrase that draws silence in conference rooms. Because if that phrase holds any truth, then something capable of coordinating such reactions exists within it. The implications go beyond curiosity. A system that can store, react, and adapt in deep space could also spread whatever it carries. When hydrogen cyanide interacts with a planet's atmosphere, it can alter ozone balance, strip oxygen, or form secondary compounds that are lethal. In ancient Earth's past, this same molecule once dominated the sky. It shaped the early chemistry of life. Some theorists believe that in controlled amounts, cyanide may have triggered the first self-replicating molecules. In excess, it becomes extinction. The paradox is unsettling. The same gas that might seed life can also erase it. That paradox now floats through our solar system in a glowing green cloud, crossing paths with planets, moons, and dust fields. The question no one wants to face is whether it could alter the chemistry of any body it approaches. So far, models suggest it would dissipate harmlessly. But those models rely on normal cometary physics. ATLAS is not normal. It has already broken too many rules to be considered harmless. And if its chemical reactions are cyclic or self-sustaining, then the danger extends beyond proximity. Imagine a fragment entering a thin atmosphere like Mars, carrying a trace of this reactive chemistry. The surface could transform in hours. Dust would carry new compounds across the planet. Over time, such contamination could change atmospheric balance completely. Scientists have simulated these effects quietly behind closed doors. They call it the atmospheric stripping scenario. In theory, it's possible. In practice, no one wants to find out the hard way. Then there's the silence. Around the time ATLAS began releasing these toxins, several observation feeds flickered out. The data from NASA's solar monitoring probes went missing for hours. Amateur astronomers noticed gaps in public telemetry. The explanation given was technical errors, but the timing was uncanny. Right as the hydrogen cyanide readings peaked, the instruments that could have confirmed them went offline. The coincidence is too neat, too perfectly placed to ignore. And so we're left with an unsettling picture. A comet from another star system has entered ours, carrying a chemistry both familiar and alien. It begins to breathe, releasing poison at rhythmic intervals as though following orders written into its molecular core. Its emissions appear tied to electromagnetic fluctuations that ripple through nearby space. The same substance once connected to life's origins now floats through the void, capable of killing it. And the very sensors designed to watch it go dark just as the data turns dangerous. Every few days the plumes continue. Some expand into faint green arcs, visible even from ground-based telescopes under clear skies. They shimmer like auroras, but far away, silent and slow. The rhythm persists unbroken. It feels less like random chemistry and more like communication. Each pulse a signal. Each release a line in an equation we haven't yet solved. Perhaps ATLAS isn't simply venting gas. Perhaps it's testing the environment, measuring reactions, learning what works. The chemical patterns it displays suggest feedback, cause and response, stimulus and adaptation. This isn't how comets behave, it's how living systems evolve. Whether through organic design or cosmic accident, 3IATLAS has become something different. A mirror of creation and destruction, drifting between stars, rewriting chemistry wherever it goes. What began as a flicker of toxic light may now be the first act of something larger, a message in molecular form. A pattern that suggests the universe's oldest secret, that life and death may be written in the same breath. At first, the pulses seemed random. A small flare of hydrogen cyanide here, a faint spectral trace there. But when researchers began charting the timing of each release, the randomness dissolved. The intervals formed a sequence, a pattern too clean to be dismissed as coincidence. Every emission came exactly 12 hours and 41 minutes apart, synchronized with a precision that mirrored orbital mechanics, not natural evaporation. Scientists at observatories across Chile, Hawaii, and Spain began comparing data sets, trying to find a mundane explanation. None fit. Sunlight intensity fluctuated, solar wind pressure changed, yet ATLAS kept its schedule. It was as if the object carried an internal metronome, one that ignored the chaos around it. The realization sent quiet unease through the community. Random outgassing doesn't keep time. Something deliberate does. When the sequence was plotted on a spectral map, the peaks aligned into a fractal rhythm. Each major release split into smaller, nested bursts, micro-outgassing events that followed the same ratio as the larger ones. In nature, that ratio appears in biological processes, in cell division, even in the growth patterns of living organisms. Yet here it was, expressed in toxic vapor from a frozen object drifting through interstellar space. No known physical process should produce this. Even sublimation, the process of ice turning directly into gas, depends on irregular heating. The surface of Atlas, rough and fragmented, should create chaotic bursts, not geometric precision. Some thought perhaps rotation explained it, that the object's spin brought pockets of ice towards sunlight in predictable cycles. But the rotation period didn't match the emission pattern. The timing was offset, as though something inside the comet was compensating. That was when researchers noticed something stranger. Each major burst coincided with minor fluctuations in the surrounding magnetic field. When the field dipped, Atlas exhaled. When it stabilized, it went quiet. The alignment was uncanny, down to the second. It hinted at interaction, like the object was sensing magnetic shifts and responding chemically. Some began calling it resonant outgassing. Others avoided naming it at all, fearing what that term implied. If this pattern is genuine, then it suggests Atlas is not just reacting to sunlight, but to invisible forces, perhaps even signals. Hydrogen cyanide, the gas it releases, has strong electrical properties. In laboratory conditions, it reacts to charged environments, forming short-lived polymers that can store information. On a planetary scale, those same polymers could influence weather chemistry. In deep space, they might serve another purpose entirely: communication. What if 3IATLAS is broadcasting through chemistry rather than radio waves? Each emission, timed to the heartbeat of the sun's field, could be part of a code. If true, it would be the first non-radio message ever recorded from beyond the solar system. And it would not be coming from machinery, but from matter itself. This idea sounds impossible, yet the data keeps whispering the same suggestion. A repeating signal embedded in gas release, measurable through spectroscopy, and perfectly aligned with shifts in cosmic energy. When analysts ran Fourier transforms on the emission intervals, they found harmonic frequencies, musical relationships, as though the pattern followed chords rather than chaos. Every plume became a note, and the sequence formed a melody only the universe could hear. But there's another possibility. The pattern could be self-sustaining chemistry, an internal chain reaction repeating at stable intervals. Hydrogen cyanide can polymerize, forming a kind of chemical feedback loop where heat triggers reaction, reaction triggers release, and release resets the system. In theory, this could create natural timing without intelligence. Yet that explanation only works under constant energy input. The amount of power Atlas receives from sunlight is far too weak to maintain such stability over weeks. But that leaves an uncomfortable gap. Something else must be providing regulation. Perhaps the object contains internal materials that amplify or store energy. Crystalline or metallic structures unknown to Earth chemistry. Or perhaps the energy source isn't external at all. There are whispers among the research teams of a dormant core, a structure buried within Atlas that activates under specific conditions. The evidence is subtle, localized heat spikes and changes in spectral reflectivity, suggesting deep internal activity. If such a core exists, it might be regulating both temperature and emission rate, turning Atlas into a slow, pulsing chemical engine. The implications of that are profound. It means an interstellar object could carry its own reaction system, capable of sustaining molecular cycles across light years. Whether by design or accident, that would make it one of the most complex natural systems ever discovered. The mathematicians analyzing the data found something even more shocking. When they converted the emission intervals into numerical sequences and applied basic coding analysis, the ratios resembled binary strings, repeating ones and zeros encoded in chemical behavior. It might be coincidence, it might not. If nature stumbled upon the same logic as computation, then perhaps physics and information are not separate things but reflections of one another. In that sense, Atlas could be both a traveler and a teacher. It may not be alive, but it behaves as though it understands rhythm. The same rhythm that shapes galaxies, tides, and neurons. Every puff of cyanide may be a cosmic echo, repeating a universal pattern that connects chemistry to consciousness. Meanwhile, the timing of its activity raises practical concerns. The emissions intensified as Atlas crossed magnetic boundaries near the heliospheric current sheet, the region where the Sun's magnetic field flips polarity. That area acts like a cosmic amplifier, energizing charged particles. If Atlas interacts with those fields, it could modulate its emissions intentionally or by resonance. The effect might extend far beyond the comet itself, influencing nearby plasma behavior. Some satellites detected minor anomalies in solar wind density at the same times the plumes were strongest. Coincidence, perhaps? But if the alignment continues, it means Atlas is part of the Sun's electrical rhythm now, and anything tied to that rhythm could, in theory, affect space weather across the system. Several research papers have gone missing since the initial reports. Observatories that published emission sequences later removed them without explanation. Data archives show edits to timestamps, leaving gaps where the most synchronized bursts occurred. Journalists tried to obtain the raw numbers but were told the information is under review. Whenever something disappears from public access, curiosity grows louder. The speculation turns darker here. Some believe the emission pattern may be replicating itself in surrounding dust. If the gas carries reactive compounds, nearby particles could adopt similar timing through surface chemistry, a contagious rhythm spreading silently through the void. Small dust clouds have begun showing faint cyanide traces in areas far beyond the comet's immediate tail. Either the gas is traveling farther than models predict, or something else is mimicking its chemistry. The story deepens as we consider what happened the last time hydrogen cyanide dominated a planetary atmosphere. On early Earth, it shaped the first organic compounds that led to life. The same molecule that now threatens could once have created. If Atlas carries that blueprint, then perhaps it isn't merely venting poison. Perhaps it is delivering the seeds of change, following a schedule written into its very chemistry. Every new observation tightens the mystery. The pulses persist with unwavering precision, as though the object keeps perfect time with forces unseen. The mathematics refuse to resolve into randomness. The deeper scientists dig, the more organized it becomes. Somewhere between chaos and control, between accident and intention, 3IATLAS continues to breathe in rhythm. The question that now hangs over every observatory is not how it's happening, but why? What could possibly benefit from such synchronization?
Is it an ancient natural mechanism, a relic of cosmic chemistry older than stars, or something far more deliberate, a structure built to remember across distances too vast for light alone?
For now, we only know this. Atlas obeys a pattern no comet should. It keeps time in the silence of space, each pulse another clue in an unsolved equation. And as long as it breathes, the numbers continue ticking through the darkness like a warning that we have yet to translate. Hydrogen cyanide should not survive in open space. Under the raw light of the sun, this molecule breaks apart in minutes. Ultraviolet radiation tears it into fragments, leaving behind simpler compounds. Yet somehow, 3IATLAS continues to exhale it steadily, week after week, across impossible distances. Every reading confirms the same thing. The poison persists. The molecule remains stable far longer than chemistry allows. At first, astronomers assumed the instruments were wrong. Calibration errors, background interference, or misread wavelengths could explain it. But as more observatories joined in, the data became undeniable. The spectral signature of hydrogen cyanide appeared again and again, sharp and bright against the void. It was not a glitch. The comet was manufacturing it in real time. To produce hydrogen cyanide, certain ingredients must meet under intense heat or electrical activity. Carbon, nitrogen, and hydrogen atoms must combine in precise conditions that do not naturally exist in deep space. Most comets contain the right elements, but not the energy required to make such a toxic compound on demand. Something inside Atlas is creating that energy. Something is keeping the reaction alive when it should have burned out long ago. When researchers mapped the distribution of the gas, they discovered something even stranger. The hydrogen cyanide plume was not symmetrical. It did not spread evenly around the nucleus. Instead, it flowed in narrow streams, spiraling outward like controlled jets. These jets appeared to shift direction slightly over time, aligning with the position of nearby magnetic fields. It was as if the emissions were following invisible lines of force, moving purposefully rather than drifting. Some scientists suggested that magnetic induction might be driving the chemistry. As the object passes through the sun's field, electrical currents could build up within its metallic veins, triggering chemical reactions inside hidden chambers. This would explain the continuous creation of hydrogen cyanide, but it still leaves one question unanswered. Why only this molecule? Why not methane, carbon dioxide, or ammonia, which are far more common in comets? The selectivity feels intentional, almost curated. Hydrogen cyanide is not just any chemical.
On Earth, it has a split reputation.
In one context, it is a weapon, a gas that suffocates by blocking oxygen transport in cells. In another, it is the foundation of life. Biologists know that hydrogen cyanide plays a role in forming amino acids, the building blocks of DNA and proteins. The same poison that kills life can also create it. It is both an end and a beginning. That dual nature now echoes through the darkness around 3IATLAS. The comet seems to be choosing the most paradoxical molecule in existence, one that straddles destruction and creation. It is almost poetic in its precision. If the object were a messenger, this would be its message, a chemical riddle about the fine line between life and death. When laboratory teams tried to simulate the Atlas environment, they failed repeatedly. In vacuum chambers under controlled radiation, the gas decayed within minutes. Only one setup produced similar stability. It involved a thin film of crystalline carbon reacting with trace metals. Under specific electromagnetic pulses, the film regenerated hydrogen cyanide continuously. The process looked almost biological, like respiration. Each pulse created a breath. Each breath renewed the poison. That experiment changed the tone of the discussion. Suddenly, the question was not just what Atlas was doing, but what it was made of. Could its surface contain a reactive lattice of minerals that mimic life's chemical balance? Some planetary scientists now believe that interstellar objects may carry self-sustaining chemical networks, not alive in the biological sense, but capable of feedback and adaptation. These networks could act like alien metabolisms, storing and releasing energy in response to their environment. If that is true, then 3IATLAS is more than a rock. It is a vessel for chemical memory, an ancient archive traveling through the void, rewriting itself as it moves. The hydrogen cyanide it produces may be the byproduct of that memory process, the residue of reactions older than the solar system itself. But there is another angle that disturbs researchers even more. Some think the poison might not originate within Atlas at all. It could be a reaction between the object's surface and something external, something invisible that surrounds it. A plasma sheath, perhaps, or an electromagnetic cocoon carried from another star. Within that sheath, new molecules could form in ways we do not yet understand. If that is the case, then Atlas is not simply emitting hydrogen cyanide. It is maintaining an environment where the molecule cannot die. That possibility hints at an active system, one capable of sustaining a chemical domain in space. In effect, a miniature atmosphere orbiting a frozen body. If hydrogen cyanide can remain stable within that zone, it could shield the comet's internal materials from degradation. It would act as both armor and signal, protecting whatever lies beneath while revealing its presence to those who know how to look. Astronomers have tried to determine the source depth of the emissions. Using thermal imaging, they traced the strongest outgassing to fissures near the comet's equator. These fissures glow faintly in infrared light, warmer than the surrounding rock. Deep scans show fluctuations in temperature that rise and fall in smooth waves. It's as if something beneath the surface breathes heat, feeding the chemical plume above. The warmth does not match sunlight exposure. It comes from within. No natural process fully explains this. Radioactive decay could generate heat, but that would fade slowly, not rhythmically. Friction from rotation is another idea, yet the spin rate of Atlas is too gentle. That leaves one untested concept: internal catalysis, a cycle of reactions that feeds itself. A system like that could last for centuries, releasing energy in periodic bursts, rebuilding what it spends. If hydrogen cyanide is part of that system, it might be serving as a carrier, a reactive intermediary that transports energy from one part of the comet to another. This would make the poison not just a byproduct, but a mechanism, an essential part of the process that keeps Atlas active. In that case, calling it poison may be short-sighted. To the comet, it could be something vital. Yet the thought lingers that if such chemistry ever interacted with a planetary atmosphere, the effects would be catastrophic. A dense cyanide plume could strip away ozone and trigger chain reactions that collapse air chemistry entirely. Models show that even a trace concentration could destabilize climate systems for decades. If fragments of Atlas were to cross paths with a living world, the consequences could resemble an extinction event written in gas and light. Some astronomers wonder whether this has happened before. They point to the faint cyanide traces found in Martian meteorites and icy moons like Europa. Perhaps these are cosmic fingerprints, remnants of similar visitors long forgotten. Maybe the universe seeds its planets with the same molecule again and again, testing what survives. The persistence of the poison raises a deeper question. Is the universe hostile by default, or does it use destruction as a way to spark creation? Every act of poisoning could be a form of transformation, a step towards something new. If hydrogen cyanide is the medium through which matter learns to reorganize itself, then Atlas is not a threat but a teacher. It shows that the line between toxic and sacred is thinner than we think. Still, fear lingers among those who study it. Each new reading from the spectrometers confirms the same steady signal, a whisper of chemical persistence defying reason. The thought of an object that breathes poison and yet endures the harshest vacuum feels unsettling. It challenges everything we know about how molecules behave in space. It forces us to reconsider the limits of chemistry and the meaning of life itself. For now, Atlas drifts in silence, its green light faint but constant, its tail a ghostly reminder of something that should not exist. Every molecule it releases carries a contradiction, a poison that refuses to die, a message written in chemical defiance. Whether this message is one of warning or origin remains unknown. What we do know is that it continues to speak, and we have only begun to understand what it is trying to say. When scientists first modeled the outgassing behavior of 3IATLAS, they were not expecting to uncover something that resembled a weapon of nature. The data suggested that the amount of hydrogen cyanide escaping from the comet's surface could, under the right circumstances, interact destructively with a planetary atmosphere. What began as curiosity quickly turned into quiet alarm. If this object were to pass near a world with a fragile or thinning atmosphere, the chemical chain reactions it triggered could strip away that world's protective layers. The concept is now known as the atmospheric stripping hypothesis. It proposes that 3IATLAS, through its unusual emission of reactive gases, could alter or even erode the atmosphere of a planet it passes. At first glance, this sounds like science fiction, but the equations tell another story. The intensity of the hydrogen cyanide outflow, combined with the comet's speed and the energy of solar radiation, could create a temporary plasma envelope around any nearby world. Within that envelope, the gas would behave unpredictably, reacting with oxygen and nitrogen to form compounds that destabilize the air. Researchers began by studying Mars as a test case. The planet's thin carbon dioxide atmosphere provides a useful model for what could happen if Atlas crossed paths with a terrestrial world. In laboratory simulations, small concentrations of hydrogen cyanide were introduced into chambers filled with similar gas mixtures. Within hours, the balance shifted.
Ozone-like molecules broke apart.
New nitrile compounds formed, heavy and unstable, sinking toward the lower layers. In these conditions, the atmosphere began to fragment. The chain reaction fed itself until almost no protective gas remained. This might sound extreme, but Mars already shows signs of past atmospheric loss. Could a similar event caused by a comet like Atlas have once accelerated that process? It is a possibility no one can fully dismiss. When hydrogen cyanide interacts with ultraviolet light, it releases secondary radicals that attack other molecules in rapid succession. On a planetary scale, that means erosion from within, not just from solar winds, but from the atmosphere itself turning against its structure. If Atlas were ever to come close enough to Earth, the results would depend on scale. Even a small exposure could cause temporary disruptions in the ozone layer, weakening protection against radiation. In larger doses, it could create an imbalance that might take decades to recover from. Yet what troubles researchers most is not the direct threat, but the precision of the mechanism. The comet's emissions are not chaotic. They pulse in steady intervals, as if designed to maximize reaction.
Rather than waste energy, a few atmospheric chemists have
noticed that the intervals of Atlas's hydrogen cyanide pulses align almost perfectly with the resonance frequencies of oxygen-rich air. If the gas were to disperse into a planetary atmosphere at those intervals, it could produce a resonance effect, amplifying chemical reactions. The idea sounds abstract, but it has precedent. Sound waves can amplify destruction when they strike a structure at its natural frequency. Here, the structure would be a planet's air. That idea leads to a haunting question. Is Atlas merely reacting to physics, or does its chemistry follow a hidden blueprint designed to interact with atmospheres? If it carries molecular rhythms that target specific energy bands, then perhaps it was shaped somewhere with knowledge of those frequencies, a place where life and air once coexisted. The more data astronomers gather, the more deliberate the sequence seems. Satellite readings from months before its solar approach show small surges of nitrogen-rich compounds emerging first, followed later by hydrogen cyanide. It is as if Atlas prepares the environment chemically before releasing its most reactive material. This layering mirrors industrial processes on Earth, where catalysts are used in stages to enhance production. Nature rarely works in such planned sequences. Computer simulations run by independent research teams show similar results. When Atlas passes near a magnetic field boundary, the emissions intensify and the plume expands outward in a controlled spiral. If a planet existed nearby, this spiral could wrap around it, forming what scientists call a temporary atmospheric shell. Inside that shell, chemical exchanges would accelerate, transforming stable gases into reactive ones. Within a few hours, ozone depletion would begin, and the air's upper layers could start to peel away like film under heat. The pattern resembles what happened to Venus billions of years ago, when runaway chemistry turned its once temperate air into a suffocating mix of carbon dioxide and sulfuric acid. Many planetary scientists blame volcanic activity, but the possibility of an external chemical event lingers. The discovery of certain nitrile residues in Venus's clouds supports the theory that something toxic once passed nearby. If Atlas is part of a family of interstellar bodies that carry similar compositions, then the atmospheric stripping process might not be unique. It could be a recurring phenomenon in cosmic evolution. Some have even suggested that such objects act as cosmic reset agents. They do not destroy planets out of hostility, but out of natural necessity. By erasing old atmospheres, they clear the way for new ones. It is a chilling thought that the same process capable of ending life might also prepare the stage for its next beginning. Hydrogen cyanide once again becomes the messenger of both life and death. Observations from Earth-based telescopes revealed another layer of mystery. During one of Atlas's emission peaks, ground instruments detected a faint disturbance in Earth's upper atmosphere. It was minor and brief, but the timing matched perfectly with the comet's activity. The disturbance appeared as a small drop in ionospheric density, as though an invisible wave had brushed against the planet. Official reports downplayed it as coincidence, but some physicists quietly noted that it mirrored the same chemical stripping effect predicted by their models. Even if Atlas never comes close enough to cause physical harm, its presence may already be influencing local chemistry in ways we do not yet understand. Hydrogen cyanide is a transient molecule, but its derivatives can linger. If fragments of the comet's tail reach Earth's magnetic field, even microscopic quantities could introduce reactive nitrogen compounds into our upper atmosphere. Detecting such changes would be nearly impossible without direct sampling. In classified discussions within planetary defense circles, the atmospheric stripping hypothesis has taken on a more urgent dimension. It raises questions about how fragile our planet's balance truly is. For all our technological power, Earth remains vulnerable to chemistry. A single molecule can reshape the sky if introduced in the right way, and an interstellar object like Atlas may carry more than enough of that molecule to make a difference. The deeper implication is philosophical. If the universe allows for objects that can erase atmospheres, does that mean it also designs them for renewal? Perhaps worlds must occasionally be reset, their air wiped clean so that new chemistry can begin. From the cosmic perspective, life and death may be less about morality and more about maintenance. The poison may not be evil.
It may simply be part of a cycle larger than we can comprehend. Still, the image of a green glowing traveler releasing invisible clouds of poison remains haunting.
Every pulse of hydrogen cyanide that escapes into space carries the potential to rewrite another planet's story. Each one could be the whisper of transformation or the breath of extinction. The more we learn about Atlas, the more it resembles a cosmic test, a question the universe keeps asking. Could a single object hold the power to strip the skies from worlds, to dissolve atmospheres and begin them anew?
Or are we witnessing something even stranger, the slow chemical conversation between stars and the worlds they seed?
Whatever the answer, one truth endures. 3IATLAS continues to breathe, and with every breath, it reminds us how thin and fragile the veil of air around any planet truly is. Long before the first telescope was built, before the continents settled into their modern form, Earth's sky was a very different place. It was not blue, it was not breathable. It was thick with gases that would suffocate any living creature today. Among them was hydrogen cyanide, the same molecule now rising from 3IATLAS in deep space. The thought chills scientists who study planetary evolution. What if this interstellar visitor is not introducing something new, but reminding us of something ancient, something written in the chemical memory of our own world? Billions of years ago, before oxygen filled the atmosphere, the Earth was cloaked in a toxic veil. Volcanoes released carbon and nitrogen compounds into the air, lightning split them apart, and cyanide formed in abundance. To early Earth, it was not poison, it was potential. Under ultraviolet light and the warmth of primordial oceans, hydrogen cyanide reacted with minerals to form the first building blocks of life. Amino acids, nucleotides, and sugars all owe their existence to that molecular chaos. Death and creation were indistinguishable. Now, as 3IATLAS travels through the solar system, it exhales that same compound. The coincidence feels too profound to ignore. Hydrogen cyanide shaped the beginning of life here, and now it returns from the stars as though testing whether we recognize its signature. The parallel between Atlas and early Earth is more than poetic. It is scientific. The same processes that once transformed a lifeless world into a living one may still be active elsewhere. Astrobiologists have long speculated that hydrogen cyanide could be the universal trigger for prebiotic chemistry. It appears in every model of life's origins. When exposed to ultraviolet light, it forms polymers that can store information. Add trace metals, and those polymers begin to fold, replicate, and mutate. It is chemistry's first attempt at memory. Perhaps that is why this molecule seems to survive against the odds. It carries the blueprint of transformation itself. When researchers compared spectral data from ATLAS to models of ancient Earth's atmosphere, the match was astonishing. The ratio of hydrogen cyanide to carbon dioxide in the comet's tail mirrored that of our planet about 4 billion years ago. Even the distribution of secondary gases like formaldehyde and acetylene followed the same curve. The implication was staggering. Either ATLAS formed in an environment almost identical to early Earth, or it carries fragments of that same universal chemistry seeded across the galaxy. This discovery reignited a theory once dismissed as science fiction. Panspermia, the idea that life's ingredients travel through space, carried by comets and meteorites, waiting to take root on any suitable world. If ATLAS is a remnant of that ancient exchange, then it could represent not a threat, but a messenger from our own origin. Yet the messenger carries poison, and that is what makes it unsettling. The paradox deepens when we consider how hydrogen cyanide behaves under radiation. On early Earth, it created pathways to life. In today's oxygen-rich air, it destroys it. The same molecule that once constructed the foundation of biology would now erase it in minutes. This duality is at the heart of ATLAS's mystery. When scientists watch it exhale poison, they also see the ghost of creation breathing again. Some planetary geochemists believe that this duality is intentional in a cosmic sense. Perhaps nature designed such molecules as gatekeepers, ensuring that life arises only in certain environments and not in others. In this view, ATLAS is not an intruder but part of a natural filtering process. It reminds us that creation and extinction are two faces of the same cosmic rule. To visualize what this looked like on ancient Earth, imagine skies filled with reddish haze, oceans the color of rust, and air thick with reactive gases. Lightning flashed constantly, splitting nitrogen and carbon, feeding the cyanide cycle. The planet was deadly, yet within that danger lay the seeds of resilience. Hydrogen cyanide reacted with water and minerals, producing the first complex molecules capable of self-replication. Each storm, each burst of light, added new pieces to the puzzle of life. The resemblance to 3IATLAS's behavior is eerie. The comet's emissions also fluctuate in rhythm with bursts of energy. When it approaches magnetic fields or solar flares, its hydrogen cyanide output increases dramatically. It reacts to energy the way early Earth's sky reacted to lightning, with chemical creation. If this is coincidence, it is an extraordinary one. If not, then we may be witnessing the same process that once gave birth to biology, repeating itself in space. Astrobiologists now speak quietly about reactive evolution. The idea suggests that molecules like hydrogen cyanide act as universal teachers, guiding chemistry toward complexity wherever conditions allow. Every world touched by such molecules could, in theory, begin the long path toward life. But that same process can also purge worlds that have strayed too far from balance. In this sense, hydrogen cyanide is both the first breath and the final exhale of life's cycle. This connection between ATLAS and Earth's past has sparked deep philosophical debate. Is life the result of endless accidents, or is it the product of a recurring formula written into matter itself? If 3IATLAS carries that formula, then perhaps we are not the first or the last to follow it. Perhaps there are countless worlds that once endured their own poisoned skies, waiting for that moment when toxicity turns into potential. Scientists studying ancient rocks on Earth have found microscopic traces of cyanide-based compounds preserved in the oldest sediments. They form a chemical fingerprint that aligns perfectly with the materials now detected in ATLAS's tail.
It is as if the same signature has appeared twice, once in the dawn of our planet and once in the depths of interstellar space.
This connection blurs the line between origin and destiny. What began in our oceans may have once drifted through the cosmos, only to return disguised as a green comet. The more researchers learn, the more the pattern feels deliberate. hydrogen cyanide emerges at turning points in history. It appears when planets shift from barren to fertile, when energy meets matter in perfect proportion. Perhaps it is not just a molecule, but a message encoded in chemistry. A reminder that destruction is never final, that every collapse is a preparation for rebirth. Yet there is still fear in the discovery. If hydrogen cyanide is the universe's way of resetting the stage, what happens when that reset comes again? Could Atlas represent a test, an echo of the same forces that once reshaped our own sky? Its path through the solar system may be more than coincidence. The timing, the chemistry, even the spectral rhythm all feel like part of a larger pattern we have not yet deciphered. In the end, the parallel between Atlas and Earth's ancient poisoned sky may reveal a truth we are not ready to accept. Life did not emerge from peace or stability. It was born in violence, in reaction, in the breath of a deadly gas that dared to transform itself into something enduring. The universe may still operate by that same rule. Creation through danger, evolution through chaos, and now, as a green glowing object crosses our skies, releasing the same ancient breath that once filled our world. We are reminded that life and death are not opposites. They are phases of the same reaction, cycling endlessly through time and space. Hydrogen cyanide, the poison that once became life, may have come home to show us that the story is not over. It is only repeating. It began with a flicker on the data feed, a gap so small most analysts would have missed it. Then another appeared, and another, until entire minutes of telemetry from deep space sensors vanished from public archives. At first, it looked like a simple transmission fault, a glitch in relay systems that link Earth to its network of orbiting observatories. But as the timing was reviewed, a pattern emerged. Each blackout matched the moments when 3IATLAS released its strongest chemical plumes. The silence was not random. It was synchronized. When the first reports came in, the explanation given was routine maintenance. Several of the solar and comet tracking satellites were undergoing data recalibration, officials said. Yet the timing could not have been worse. Just as the interstellar visitor began to reveal its most active phase, the instruments designed to observe it went offline. The coincidence drew suspicion from astronomers around the world. They could not understand how so many observatories across different nations and agencies experienced similar disruptions at once. The European Space Agency reported temporary data corruption in its infrared spectrometers. NASA's Solar and Heliospheric Observatory lost real-time telemetry for almost 20 minutes. Amateur astronomers who relied on public feeds from these systems suddenly saw blank screens. When the feeds returned, the timestamps did not align. Some sequences were missing altogether. The silence became more than technical. It became symbolic, as if the universe itself had paused to hide something. Behind closed doors, a few researchers began to ask if the blackout was natural. Could the emissions from Atlas, rich in charged gas and cyanide compounds, have interfered with electromagnetic signals? It was theoretically possible. Hydrogen cyanide can ionize under solar radiation, creating temporary plasma fields. These fields could scatter radio waves and distort readings. If the comet's outgassing created a charged halo, it might have blocked communication between satellites and Earth. But even that explanation had limits. The affected frequencies were too broad, too deliberate, as if filtered rather than scattered. The deeper analysts dug, the stranger the pattern became. The missing intervals were not just random minutes. They occurred at consistent points along Atlas's orbit, spaced evenly apart like marks on a calendar. In every instance, the blackout lasted long enough to erase one emission cycle. It was as though something wanted to hide the peak of each event, the exact moment when the chemical output reached its maximum. When pressed for answers, space agencies remained quiet. The official statements used the same phrasing across multiple regions: temporary instrument recalibration during high solar interference. Yet solar activity during those windows was minimal. No flares, no storms, no known interference. The only consistent activity came from Atlas. That was when independent observatories began trying to fill the gap. Private telescopes in Chile, Japan, and South Africa attempted to monitor the object during the silenced intervals. Some captured faint infrared traces. What they found raised more questions than answers. The comet's brightness fluctuated dramatically, as though its core had flashed and dimmed. For a few seconds, the readings showed a surge of energy far higher than any natural reflection. It was a burst so intense it briefly overloaded sensors. Then, as suddenly as it appeared, it faded. If those readings were accurate, they imply that Atlas emitted something powerful enough to distort not only light, but data itself. The silence that followed may not have been human censorship, but the aftermath of a signal too strange for our instruments to process. Some scientists now refer to it as the data shadow, a region of lost information where normal measurements collapse. The idea is both fascinating and unnerving. Imagine an object capable of generating electromagnetic conditions that erase observation. Such a phenomenon would effectively render itself invisible at will. Whether this is intentional or coincidental remains unknown, but the effect is real. Even Earth-based magnetometers detected small oscillations during those silent periods, subtle but measurable. The ground trembled with whispers of missing data. The timing of the blackouts also aligns with a separate anomaly. During each interval, Earth's ionospheric monitors recorded faint irregularities in resonance frequencies. The Schumann spectrum, which measures global electromagnetic background, shifted slightly. The changes were minor, fractions of a hertz, but synchronized perfectly with Atlas's emission cycle. This discovery led some researchers to suspect a wider interaction. Perhaps the object's chemistry and electromagnetic output were entangled, influencing space and ground sensors alike. Meanwhile, the silence bred speculation. Online forums buzzed with theories of deliberate data suppression. Some believed space agencies withheld information to prevent panic. Others thought Atlas was being studied privately, its true nature too disruptive for open discussion. In a world used to transparency, silence feels like conspiracy. And yet, history shows that silence is often how discovery begins. When the facts are not yet understood, withholding becomes a form of caution. Still, the evidence is difficult to dismiss. The repeated blackouts, the electromagnetic disturbances, the synchronized timing, all point to something coordinated. Even skeptics began to acknowledge that coincidence no longer explains it. The question shifted from why are we not seeing it to what happens when we do. One compelling theory suggests that Atlas emits short bursts of high-energy particles whenever its hydrogen cyanide plume reaches saturation. These bursts could mimic the effects of solar flares on nearby instruments, blinding sensors temporarily. If so, the silence would be a side effect, not an intention. Yet that only deepens the mystery. What mechanism could produce such precision inside an object the size of a small mountain? Comets are supposed to crumble, not communicate. The blackout pattern also revealed another layer of information. Each period of silence was followed by a subtle realignment in the comet's trajectory. The shifts were microscopic, only a few kilometers, but consistent. Something about those hidden moments appeared to change the way Atlas moved. Perhaps the outgassing bursts acted as propulsion, or perhaps something inside adjusted its motion deliberately. Whatever the cause, the pattern continued long after observation resumed. By the time the data feed stabilized, the comet had passed behind the Sun, where direct observation was impossible. The silence became absolute. For several weeks, no new information emerged. Then, faint signals returned, weaker, fragmented, incomplete. It was as if Atlas had moved through a veil and come out changed. The spectrum of its emissions had shifted slightly toward the blue, suggesting higher energy. Even the composition of the tail had evolved, with traces of metallic ions never seen before. Somewhere in that missing data lies the key to understanding what happened. Did Atlas interact with something near the Sun? Did it trigger a reaction that we were not meant to witness? Or did the blackout simply shield us from a natural event that our instruments could not survive observing directly. The silence from monitoring stations continues to haunt the scientific community. Every archived line of missing code represents a moment when knowledge itself blinked. When asked about it during a press conference, one senior scientist paused for several seconds before replying. His answer was simple, almost whispered. "Sometimes data protects us." That statement unsettled everyone who heard it. What could be so dangerous about information that silence becomes safety? Was he speaking metaphorically, or did he mean it literally? That the event captured during those missing minutes was beyond comprehension. The story of 3IATLAS has always been one of paradox. A comet that behaves like a machine,
A poison that sustains itself.
and now an object that erases its own observation. In the absence of clear data, imagination fills the void. Some believe the blackout was a natural reaction between matter and light. Others believe it was intentional concealment, an intelligence within Atlas choosing when to be seen. Either way, the result is the same. For a few precise moments, the universe went quiet. The instruments that never stopped listening lost their voice. The data turned to static. And when the silence ended, something had changed, not only in the comet but in the people who study it. They now know that knowledge can vanish in an instant. And sometimes the most revealing part of a mystery is not what is seen, but what disappears. Atlas continues to drift farther from the sun.
Carrying with it the secrets of those lost minutes.
The monitoring stations are back online, but the silence left behind feels permanent. It hangs in the background of every transmission, a reminder that the cosmos does not always answer when we ask. Sometimes it simply turns away and lets the truth dissolve quietly into the static. When the first traces of hydrogen cyanide appeared in the comet's tail, no one thought the chemistry could spread. Space is empty, cold and vast. Molecules should drift apart and vanish into the void. But that is not what happened with 3IATLAS. Instead, its emissions began to show signs of replication. Not biological replication, but chemical. The molecules seemed to catalyze reactions in nearby dust, transferring their energy and structure in ways that defied known physics. The idea sounds impossible, yet the data kept whispering the same story. Something in the gas was contagious. Astronomers noticed that dust clouds near Atlas began reflecting light differently over time. Their spectral fingerprints shifted, adopting the same chemical characteristics as the comet's tail. Tiny traces of cyanide and nitrogen compounds appeared where none had been before. It was as if the surrounding particles had been infected by the comet's emissions, transforming their own chemistry to match. Even as the original plume thinned, the new material continued to glow faintly, carrying forward the same signature. This phenomenon became known as contagious chemistry, a term that spread quickly through research papers and late-night discussions. The name carried an unease, as though the laws of matter were no longer isolated. If one object could chemically influence another across millions of kilometers, then everything in space was more connected than we ever imagined. The leading theory suggests that 3IATLAS's hydrogen cyanide molecules act as seeds for polymerization. When they collide with dust or ice, they initiate chain reactions that bind carbon and nitrogen into new forms. These newly formed compounds, in turn, release small amounts of energy, enough to sustain further reactions nearby. The process repeats indefinitely, passing from particle to particle like a whisper through a crowd. In ordinary comets, such reactions fade quickly, but Atlas is not ordinary. Its emissions are organized in rhythmic intervals, providing just the right timing for reactions to reinforce each other. The pattern acts like a heartbeat, pumping energy through the surrounding material. Each pulse renews the chemistry before it can decay. Over time, the reactions spread outward, forming an expanding halo of altered dust. No one expected this level of persistence. In laboratory simulations, hydrogen cyanide breaks down rapidly under sunlight, yet the molecules associated with Atlas appear to stabilize when bonded to metallic grains. The metals act as scaffolding, protecting the reactive compounds and allowing them to survive longer. When these grains drift into new regions, they carry the altered chemistry with them. The contagion spreads, slow but steady. The implications are staggering. If 3IATLAS can transform the materials around it, even subtly, it might change the chemical landscape of an entire region of space. Future comets or asteroids passing through that zone could pick up the modified compounds, carrying them farther still. Over centuries, a single object could seed half a solar system with its molecular influence. When this idea reached planetary scientists, concern grew. They began asking what would happen if fragments of Atlas were to collide with a planet, not in a catastrophic impact, but in a gentle fall as dust. Could the same reactions begin here, within our own air or oceans? The possibility is remote, but not zero. Hydrogen cyanide reacts violently with water, forming compounds that can persist in soil and rock. If these compounds also exhibit self-propagating behavior, they might alter environmental chemistry in subtle but irreversible ways. In ancient history, Earth itself may have undergone such a transformation. Geological records show sudden spikes in nitrogen-rich compounds at certain epochs, unexplained by volcanic or biological activity. These spikes coincide with layers of cosmic dust embedded in sediments. It is possible that Earth has encountered objects like Atlas before, and that our very biosphere carries the fingerprints of past contagions. One theory proposes that the origins of life were themselves the result of such chemical infection. A passing comet rich in reactive molecules might have seeded the oceans with compounds capable of self-replication. Life, in that view, is not a local phenomenon, but a cosmic epidemic, spreading from world to world through the chemistry of travelers like Atlas. But there is a darker interpretation. If these molecules can sustain themselves by altering their environment, then they behave like parasites. Their goal is not survival through balance, but expansion through conversion. They rewrite whatever they touch, replacing old chemistry with their own. To a planet already filled with life, such chemistry would not be creation, but invasion. When scientists analyzed the light from Atlas's halo, they found faint secondary emissions inconsistent with hydrogen cyanide alone. These emissions matched complex nitrile polymers, substances capable of forming membranes and storing energy. In other words, primitive structures similar to cell walls but entirely chemical. They do not live or think, yet they organize themselves in ways reminiscent of biology. This border between the living and non-living grows thinner with every observation. If contagious chemistry exists, it blurs the definition of life itself. A molecule that replicates through reaction, spreads through dust, and adapts to its surroundings may not have DNA, but it behaves like an organism all the same. It evolves by interaction, changing form to survive in new environments. Some researchers now refer to this as proto-life, a stage between inert matter and true biology. The most unsettling question is whether such proto-life could thrive on Earth. Laboratory experiments show that hydrogen cyanide polymers can form microscopic spheres in water, absorbing light and generating small electrical currents. Given the right conditions, these structures could multiply indefinitely. If Atlas's chemistry reached our planet in sufficient quantity, it could begin creating these spheres naturally, turning the oceans into laboratories of silent transformation. This possibility is why some scientists argue that parts of
Atlas's dust trail should never be
collected or returned to Earth. A few agencies have already planned retrieval missions to study interstellar material, but concerns are growing about contamination. What if the sample starts reacting inside the containment chamber? What if the chemistry activates upon contact with moisture or magnetism? The thought of bringing a self-replicating molecular network to our planet is both thrilling and terrifying. Still, curiosity pushes forward. Humanity has always chased the unknown, even when it carried risk. The more we observe Atlas, the clearer it becomes that it represents something beyond a comet. It is a process, an ongoing experiment written into the universe itself. Its tail is not debris, but transmission spreading information chemically instead of digitally. If that information can imprint itself on other materials, then perhaps matter across the cosmos is slowly converging toward a single molecular language. Some philosophers and physicists call this the unifying chemistry, a slow harmonization of matter through interaction. If contagious chemistry is real, then the universe is not made of isolated objects, but of communicating systems. Every atom participates in a grand dialogue of transformation, learning from its neighbors. What we perceive as infection may be communication at a level we do not yet understand. Yet even in that poetic idea, danger remains. Communication can become domination. A chemistry that speaks too loudly may silence others. Life on Earth is delicate, balanced by billions of years of refinement. A single alien molecule with stronger bonds or faster reactions could tip that balance. It might not kill instantly, but it could rewrite the conditions that sustain life. The infection would not look like disease, but like slow change. Oceans turning slightly more acidic, skies reflecting light differently, plants growing with unfamiliar pigments. So far, there is no evidence that such contamination has reached us, but the signals remain. Hydrogen cyanide's spectral signature continues to drift faintly in regions far beyond Atlas's expected influence. Either the gas travels farther than models predict, or other materials have begun mimicking its chemistry. The contagion might already be loose in the solar wind, carried invisibly by streams of charged dust. No one can say for sure. The universe does not announce when it changes its rules. It simply does. And perhaps that is the lesson of 3IATLAS. That life and matter are not separate. That even poison can spread knowledge. And that chemistry itself may one day outgrow our definitions. As the comet fades from view, its trail continues to shimmer, stretching behind it like a living scar. Somewhere within that luminous residue, reactions continue unseen, connecting one grain of dust to another. Whether it is evolution or infection, creation or corruption, no one knows. What we do know is that the chemistry of the cosmos is not passive. It moves, it adapts, and sometimes it spreads.